Now we're going to start talking about efficiency. We learned in class that efficiency is the ratio of input work to output work of a machine. Usually we measure efficiency as a percent. Okay? So our equation that we decided on in class is efficiency as a percent is equal to the work out of the machine divided by the work into the machine times 100 to make it into a percent. This number right here, the work out divided by work in, should always be less than 1. And then when we multiply it by 100%, that should always give us a percent less than 100. If we have a number that is greater than 100, what that means is our machine is creating more work. Machines don't work that way, all right? Machines will always lose a little bit of energy or lose a little bit of work when they do work, right? Okay, a little bit of it is lost, and we're going to talk about that later on in the semester. We could also put this into a triangle if we really wanted to. If I have a triangle here, on the right side of my equation, I have a fraction, right? I have something divided by something else. So what's on top is going to go on top of my triangle, which is work out, and then work in is going to go on the bottom of my triangle. And I can also put efficiency here, and I'm going to put E percent to remind me that this is efficiency. Later on, we're going to use E to represent energy. So I want to make sure that we're not getting confused. E right now stands for efficiency, and I always put that percent next to it to remind us that it is a percent efficiency, okay? So now we're going to do a couple of practice problems. The first one is a machine needs 104 joules of input and produces 71 joules out. What is its efficiency? So we know that our two numbers are 104 and 71. We have joules for both of them, which tells us that they are both work. We know that my equation is efficiency as a percent is equal to work out divided by work in times 100. Well, which one of these is my work in and which one of them is my work out? This problem is kind of easy because it says 104 joules of input and 71 joules out, or produces. So input tells me that this 104 joules is in, and then the words produce and out tell me that this is the work out of the machine. So now I can put those into my equation. Efficiency as a percent is my work out, which is 71 joules, divided by my work in, which is 104 joules, times 100. My joules on the top and on the bottom cancel out. We said that anything divided by itself is always equal to 1, and so we can cross it out. It does not matter. So now I need to put this into my calculator. So I'm going to start by doing 74 divided by 104. And that gives me 0.7115, and it keeps going, but that's all I'm going to write. Now I can multiply this number times 100. And that gives me 71.15, and then it keeps going. But I'm going to round this to the nearest percent. So when I look at this 0.15, that's going to round down. So my answer is going to be 71%. That is my answer. That is my percent efficiency for this machine. My next problem says calculate the efficiency of a light bulb if it produces 30 joules while 95 joules is used. All right. Well, like we just said, efficiency in percent is equal to my work out divided by my work in. Here, it's not actually work. We're talking about energy. The equation for energy efficiency is the same, all right? Energy out divided by energy in. Because you're going to say a light bulb doesn't exert a force over a distance. That's true. Okay. So right now we're just looking at efficiency though. So what goes out divided by what has to go in. I know I have 30 joules and 95 joules. My big context clue here is produces. Produces tells me that this 30 joules is out. Okay, our energy and our work out is always going to be smaller. So that's another really good one to use. With mechanical advantage, that's not always true. But with efficiency, that is always true, okay? The out is always going to be smaller than the in. So I have 30 joules out divided by 95 joules in. My joules cancel out. And that gives me 0.316. But we're saying, hold the phone, we forgot something. We need to multiply this times 100 to make it a percent. That's right. So we need to take this 0.316 and multiply it by 100 to get a percent. When I do that, the calculator shows me 31.6%. That is my answer. My last problem says a bicycle is 95% efficient. If 89 joules is being output, how much work is going into the bike? So here, am I calculating efficiency? I'm not. It gives me my efficiency. So this is a time where I might want to break out the triangle. And we know that efficiency percent is equal to our work out divided by our work in, right? So now we have to figure out what's what. 95%, 89 joules. Those are the two numbers that I get. Efficient is my context clue here. Output is my other context clue. So efficient goes with the 95%. Output goes with that 89 joules. So this must be our W out, and this must be our efficiency as a percent. So then what am I looking for? It says how much work is going into the bike. So this must mean I'm looking for my W in. So if I'm looking for my W in, I would cover that up with my finger. And that tells me that my work in is going to be my work out, and it's above, so it's divided by my energy as a percent. So now I can solve this. I can say that my work in is equal to my work out divided by my efficiency. So my work in or my work out, sorry, my work out is 89 joules. And then I divide by my efficiency. But when we divide by our efficiency, we're not dividing by 95. Because what do we have to do after to get our efficiency? Multiply by 100%. So what we're actually going to do is take that 95% and to turn it into not a percent, we have to divide by 100. So 95 divided by 100 is going to be 0.95. If this is confusing, it's okay. It's confusing. It's because we have a percent here that we need to turn into a number. Okay. We could also do 89 divided by 95 and then divide by 100. Okay. That would also be a great way to do it. So now I'm going to take my 89 divided by that 0.95, and that gives me an answer of 93.7. What are my units for work? My units for work are joules. So my answer for this problem is 93.7 joules. If we didn't divide by 100 for this 0.95 right here, we would have gotten an answer of 0.93. And we could have looked at that, or 937, right? We could have looked at that and said, whoa, hold the phone. Our work in is always going to be bigger than our work out. Always, always, always. 0.937 is not bigger than 89 joules. I must be missing a step, or I must have done a step wrong. Okay. And then we could go back and say, oh, I forgot to undo the multiplying by 100. So I need to do that again. And then it's 93.7. Okay. So hopefully now you understand what efficiency is, and hopefully now you have the tools and the practice to be able to solve for efficiency on your own.